Okay, this lecture is going to be on the topographic features of the Atlantic and the Pacific Oceans. So we're going to start out with the Atlantic Ocean. So we're going to start out on the East Coast, head across the Atlantic Ocean, and end up over in Europe. So first we're going to start out with, let's say that's my land. Here's my continental shelf, my continental slope, and my continental rise. So now I'm going to go back and label it. Continental shelf, continental slope, and the continental rise. Now the continental shelf and slope, this is mostly terrigenous sediment, meaning the sediment that lands in here and forms the shelf and the slope comes from the land. So rivers come through carrying a lot of sediment, it hits the ocean, and the sediment kind of drops and falls on the continental shelf. Continental slope, I'm also going to add in here, we can get sub means below or beneath, submarine canyons. Formed by turbidity currents. So this water coming from the land, carrying lots of sediment, might have a really high density. That water, since it has a really high density, is going to sink pretty rapidly. So once it hits this continental slope, it kind of rushes down. And when it rushes down, it carves out these canyons in the continental slope. Once it hits the bottom, it kind of fans out, and all the other sediment's going to drop and form the continental rise. So the continental rise is also mostly terrigenous sediments. Now I'm going to pause, and I'm going to draw a line here. This dashed line represents the boundary between a continental plate and an oceanic plate. So the continental shelf, continental slope, that's all part of the continental crust, whereas the continental rise on over is going to be made up of the oceanic crust. And again, before I move on, I'm going to label this side the United States East Coast. Something else I'm going to label here, this is also called a passive margin. A passive margin means there's no active plate boundary here. So yes, you could say there's a plate boundaries between a continental plate and oceanic plate, but there's no convergent boundaries, there's no diverging boundaries, there's no like transform boundary. So there's no movement happening in between here. When there's no movement, we tend to get larger continental shelves because the rivers have more time to build that up. You'll get more of a gentle continental slope, and you'll get more of a continental rise. Okay, moving on our journey. After the continental rise, we have the abyssal plain. After the abyssal plain, we'll start to get some bumps. We call these abyssal hills. The abyssal hills are actually old mid-ocean ridges that are starting to get buried. So over time we have what's called marine snow, which is dead organisms, and that's going to fall down the ocean. It's going to slowly bury my mid-ocean ridges. So all we're really looking at is the top of my mid-ocean ridges. So eventually we'll get a bigger mountain. So this is a mid-ocean ridge, MOR. And here we have a rift valley and another mid-ocean ridge. Here we have the division of another plate. So my oceanic plate is moving this direction, and this oceanic plate's moving that direction, so it's a diverging plate boundary. Diverging plate boundary. So you need to know that at diverging plate boundaries, we get mid-ocean ridges and rift valleys. Okay, moving on, you'll see sort of a mirror image. We have some more abyssal hills. That slowly lead into a abyssal plain. That abyssal plain will lead into the continental rise, the slope, the shelf, and then on up to the land. Again, we may get submarine canyons. In the slope. Here's our continental shelf. Over on this side we have Europe. I'm going to make my boundary again. So we have a continental plate over here. This side's oceanic. And this was also considered a passive margin. Because these plates are not moving in relation to each other. And that's it for the Atlantic Ocean.